In this tutorial, we will look at how we can model pressure reducing valves in our water distribution model. So, as the name gives away, the function of a pressure reducing valve is to reduce the pressure. These valves are used to create pressure zones, which we will cover in tutorial number 9. It is useful to model the pressure reducing valve manhole as close as possible to how the valve is set up in the actual system. So get a drawing of how your manhole is built and try to replicate it as close as possible. Often manholes for pressure reducing valves have 2 piping segments with their own pressure reducing valve, like in this example drawing here. But the most important thing to model correctly is the setting of the valve, meaning to what pressure it should reduce to. Before we move on to model our pressure reducing valve in Fictionville's water distribution system, it is important to understand the different states the pressure reducing valve can be in due to the system's behavior, especially when we will interpret the simulation results. Here we see a pressure reducing valve with a setting of 50-meter water column. The pressure on the high pressure side is 65-meter water column. This means that when there is a demand or need for water on the low pressure side of the valve, the demand will be met and the pressure will be 50-meter water column out of the valve here. If, on the other hand, we have the same pressure of 65-meter water column on the high pressure side, the setting of the valve is still 50-meter water column, but the pressure on low pressure side is higher than the setting, for example 55 meters. Then the pressure reducing valve will behave as a closed valve, meaning it will not deliver any water. This is because you cannot reduce the water because the zone you are reducing to has a higher pressure than the setting of your pressure reducing valve. Lastly, we have a situation that can be common for extraordinary situations, like when we have an outfall of a water distribution element, or there is water demand for firefighting purposes. This is when the pressure on the high pressure side is lower than the setting of the pressure reducing valve. When this happens and the valve needs to deliver water, then the pressure reducing valve will behave as an open valve, meaning that it will not change the pressure or anything to the water passing it. The only thing that happens is that you get some minor losses. So this is it for the different states that the pressure reducing valve can be in. Very important to know in general, and especially important when modeling and understanding our simulations. Now we'll move on to creating our pressure reducing valve for Fictionville's water distribution system. So for this system, there is only one pressure reducing valve, and according to the map here, the pressure reducing valve is here, and reduces the water going south from this manhole. So what we need to do in order to model it is that we first can zoom in to it a little bit, and then we go to WD network here, and our target layer is a valve, but in order to model it, we need to create some junctions so that our valve can be between 2 junctions. So I'm just going to create one more junction and just should be careful with how you place it in case it becomes too long, but I'm just going to do it roughly here. And I'm going to say yes to split the pipes. And when I've done this, I've, as I said, split the pipes. We have 2 pipe segments, but I want to delete this small pipe segment, because I want my valve to go between these junctions. So this is how we model it in water distribution systems. And now for drawing out the valve, I need to choose valve here. I need to click on the create. And the important thing when modeling pressure reducing valves is that we need to draw it in the direction that it will reduce the water to. So it's going from here on the high pressure side to the low pressure side here. And when I go to the junction that it will end on, I just double click on that junction. And now I can press escape, because I'm not going to draw any more, keeping it simple for this system here. So when I use my identify tool here, which I use a lot to identify the system components and the results when we get there, you see on the right hand side we get the information. So it has a diameter, it has the valve type, which we will set to PRV, meaning pressure reducing valve. And we could get technical here and have some loss coefficients and get the minor losses and everything for this valve, but normally we just regard the system friction losses and losses in general, and we don't care for the minor losses in a big system. But that of course depends on the size of the system and what information you have. But this is pretty normal. And the other thing that we need to provide here is the setting. So I'm gonna put this to be 30 meters, meaning the meter water column. So if the pressure here is 60, then it will be 30 here when it reduces through the valve. And this is basically everything. We have the from node to node, so we see the direction. And if I take away the identify and zoom in, you can see there's an arrow here, symbolizing where the water is being transported through the valve. And this is pretty much it for modeling pressure reducing valves. You can choose the status here to be open, or if you have two in a manual, you can have the other one being closed, for example. And but the thing that we normally have is that we have it regulating, meaning that it will be acting accordingly to how the system is behaving, as we looked previously on the 3 states that the pressure reducing valve can be in. And I think that's enough for now. So I think I'm going to leave it here. We have successfully modeled in our pressure reducing valve here according to the system properties, and I'll see you for the next tutorial when we will be modeling pumps in this model. So stay tuned for that video. Have a great day, and I'll see you soon.